All right, so I think this is recording. Let's take a look at solving these two equations. They are rational equations. We see that because there are variables in the denominator. And of course, when we have variables in the denominator, we have to be concerned about division by zero. So we need to check our answers to make sure they are not extraneous solutions. So let's jump in and start with number 5. When we look at it, we see a denominator of x plus 3 and x minus 2. And on the right-hand side, that denominator is a trinomial that we'll want to factor. And you can see, I think, by inspection that this x squared plus x minus 6 is going to factor to x plus 3 times x minus 2. So that's kind of nice that we recognize that right away, because now I can see that this first term is missing a factor of x minus 2. So I'm going to write x minus 2 over x minus 2. The second term is missing a factor of x plus 3. The right-hand side, we've already commented that we recognized that we can factor this into x plus 3 times x minus 2. So therefore, all the denominators are the same except for the order of multiplication, and we know that multiplication is commutative. If we multiply all the terms, both sides of this equation, by that common denominator, all these denominators will clear. And what we'll be left with is just the operations that's in the numerator. We'll have x times x minus 2. We'll have x times the quantity x plus 3, and that will equal 10. But before we go any further in trying to solve this, we need to look and recognize that since we did have a variable in the denominator, that we do not want to allow -3 to be in the solution set. If it turns out to be a solution to this equation, we're going to call it extraneous. And over here, x minus 2, we're going to throw out positive 2 as well. So when you multiply both sides of an equation by a variable, you introduce the possibility of an extraneous solution. So we need to be aware of that. All right, so let's try to get this in some kind of standard form. We've got x squared minus 2x minus x squared minus 3x is equal to 10. The x squared minus x squared cancels. We have negative 5x is equal to 10. Divide each side by -5, and I'm getting a -2. -2 is okay. -2 should check. It is not one of these values that would cause division by 0. All right, so let's take a look now at number 6. I'll leave it up to you to plug in -2 and see if the left-hand side and right-hand side are equal to each other. That's just arithmetic. That can be done on a calculator as well, right? All right. In this problem number 6, again, we have the same situation that we did in 5. On the left-hand side, we have linear denominators, but on the right-hand side, a quadratic. And x squared minus 7x plus 6 factors. You can easily see that it factors to x minus 1 times x minus 6. -1 times the -6 is positive 6. And -1 and -6 add up to -7. So we're going to do this problem in the same technique, the same way we did the last problem. The only thing is different is the actual values, but the method that we're doing for our solution is the same method. This first term, the denominator is missing a factor of x minus 6, and the second term It has the x minus 6, but it's missing the x minus 1. But by multiplying with the numerator and denominator equal to each other, we're just multiplying these terms by the number 1, so we're not changing the value. Changing the appearance, but not the value. So on the right-hand side, I have 5x squared minus 15x plus 20. And in the denominator, we've already made the comment that this factors to x plus 1. No. X minus 1 and x minus 6. All right, so we're going to multiply both sides of this equation by that common denominator. That's going to cancel all these denominators. But in doing that and multiplying both sides of an equation by a variable, we introduce the possibility of extraneous solutions. And we need to make some notes to ourselves now that if x were allowed to equal 1, if we allow 1 in the solution set, it'll be making a serious mistake, because in the original equation, if x equaled 1, you would have division by 0, and that would be undefined. So, and we also, by the same reasoning, can't allow 6 to be in the solution set. All right, so let's come down here and work with the numerator, the operations in the numerators, and see what we have. 3x times x minus 6, 2x times x minus 1, and 5x squared minus 15x plus 20. All right, so let's apply the distributive property. Get 3x squared minus 18x. And here we get 2x squared minus 2x. The right-hand side, we're going to leave it alone for a moment. On the left-hand side, what do we have? The 3x squared and 2x squared give us 5x squared. And the linear terms here give us a minus 20x. And that equals 5x squared minus 15x plus 20. If we subtract 5x squared from each side, these terms cancel. And if I add 15x to each side, I get a negative 5x is equal to 20. Divided by a negative 5, 20, positive 20 divided by negative 5 is a negative 4. And negative 4 should be okay, because it's not one of these values that's going to cause division by 0. So I'm going to leave it in my solution set. Leave it up to you to check and plug it in and see if hopefully I didn't make any arithmetic error. If for some reason you find out that negative 4 does not satisfy the equation, it's because then that I've made a mistake in my work. It's not because that it should have been called an extraneous solution. A mistake in my work is not an extraneous solution. It's just, hey, Mr. Edsinger was dumb and made a mistake on the video. So ask questions, and like I say, let me know if I have to edit any of these videos. So hope that helps, and I will talk to you later. Bye.